In this video, you'll learn how to handle asynchronous data fetching with React Router v6. You'll learn the new API that React Router provides, and you'll learn how to take full advantage of it to build responsive web applications. My name is Larry, and this is Digital Logic. So the project that I have opened is the same project that we ended with in the last video. If you didn't watch the last video, it's no big deal. The project is very simple. So I'll open up the app component, and you can see we have some basic routes defined. So we've got a root route mapped to the home component, a nested route on the products path with the products component set as the index route and a dynamic segment for each product. Then a shared layout mapped to both the about route and contact route. If some of this doesn't make any sense to you, then you may want to check out the previous video where I covered this setup in detail. The route components themselves are all very simple, and all they do is print out the name of the route in an H2 element. We'll start out by loading a list of products into the products component, and we'll build a fake API to simulate a network request. So within the source folder, create a new file, which I'll name fakeapi.js. And then create a new function named genProduct, which will then return a new object. To help us generate fake data for our products, we're going to install an external library. So open up a terminal and type npm install at faker-js/faker. And while we're at it, also install localforge, which is all one word despite the way it looks with the carriage return. Localforge will make it easier to persist the data that we generate within the browser. Define the first property in our product as name, and give it the value of faker, and make sure to include the import .commerce.productName. Set the next property to description, and set its value to faker.commerce.productDescription. Define a price property, and give it the value of faker.commerce.price. Define a quantity property, and give it the value of math.floor, math.random, and it's supposed to be times 100, but I forgot to do it. Define an ID property, and set its value to faker.datatypes.uuid. Finally, I want to define a slug property, which will be a URL-compatible string of the product name with a random value at the end. So we need to create a new function to generate a random hash value, and I'll give it a length property, and then return math.random.toString, then pass in 36 for the radix, .substring, 2 to 2 plus length. So this function will generate a random hash that consists of the letters A through Z, 0 through 9, that is length long. Create another function named genSlug, and then pass in a single parameter, name. And then return fakers.helpers.slugify, and then pass in the name property, plus a space, and then plus genHash with the value 6. Back in the genProduct function, cut the value that the name property is set to, and then create a new constant, name, and set it equal to the value that we just copied. Then add a new property to the product object, slug, and set it equal to genSlug, and then pass in the name property. So this function will generate a single product. Now we need to create a new function that will generate an array of products. So create a new function named genProducts. I'll pass in a single parameter, size, and then return a new array, and then pass in the size property to the array constructor. Yes, I am using the forbidden array constructor. Next, call fill and pass in null. This step is critical because the new array constructor does not create an array of n elements. All it does is set the length property to n. So we need the fill function to finish the job, and then call map and pass in the function genProduct. So this function will generate our list of products. Now we just need to store it somewhere so we can access the same list whenever we need to. So add a new import for localforge from localforge. Call localforge.config and pass in a new object. define the name property and set it to catalog. Create a new constant, key, and set it equal to the string value, products. Now create a new function, genStore, and make this function async. Create a new constant, products, and set it equal to localForge.getItem, and then pass in key. This method will return a promise, so add await. If the products variable is a falsely value, then we don't have anything saved on the local computer. So we need to call localForge.setItem, pass in the key, and then call genProducts. And to start out, we'll only generate 6 products. With this store complete, now we need to create our API. So create a new constant, fake API, and set it equal to a new object. Create a new key named getProducts, and set it equal to a new function. Create a second function named getProduct, which will take a single parameter slug, and this will return the single object in the store that matches that slug value. We're going to build in an artificial delay so that the API calls behave more like network requests. So create a new function named delay. The first parameter is another function, and the second parameter is the time or the maximum delay that the API call will take, and I'll give it a default value of 3000 milliseconds. Then return a new promise. Pass in a function with both the resolve and reject parameters. And within this function, call setTimeout. Pass in another function. In this function, call the func function. And because I want the API call to be able to resolve or reject the request, pass in both the resolve and reject parameters. Finally, set the timeout value to math.random times time. Back to the getProducts function, remove the curly brackets and call delay, and then pass in a new function with both the resolve and reject parameters. Within this item, call localForge.getItem, and then pass in the key. This method will return a promise, so call .then, and then pass in a reference to resolve. Now for the getProduct function, remove the curly brackets and call delay. Pass in a new function with both the resolve and reject parameters. And this function is going to be a bit more complex than the last one, so I'll make the function async. Now create a new constant, products, and set it equal to await localForge.getItem key. Create a new constant, product, and set it equal to products.find, and then pass in a new function to check if the product has the same slug that was passed to the getProduct function. If product has a truthy value, that means we found it in the array, so call resolve and pass product to it. Otherwise, call reject and pass in a new object with a message that states something like no product with ID at slug found. Then make sure to export the fake API object at the bottom of the page. Open the index.js file and add an import for the fake API. Save the file, and in your developer tools in your browser, open up the application tab. And then in the IndexedDB, we should have something. So open up the fake API again. And I forgot to execute the genStore function. So once we do that and save the file, in the developer tools, we'll have a new caret next to the IndexedDB, and then our catalog. And then we got our products key with the array of products. React Router v6 has a few advantages when it comes to downloading data for a route. But before we explore what React Router has to offer, let's see how we would load data into a React component the old-fashioned way. So open up the products component and add a new state variable, products, and set it equal to useState. Set the initial value to an empty array, and this is so we don't have to perform a null check in the component's JSX. Add a useEffect hook and pass it a new function. Call the fake API and make sure to include the import .getProducts. This function returns a promise, so call .then, and then pass in the setProducts function. And then add an empty array as the dependency array. So now let's display the list of products in the component. Create a new div to wrap around the list of products. And then create a new component named product thumbnail. Destructure the props object and retrieve the name property, description, price, and slug. Return a JSX object, and since I want this component to be clickable, wrap it in a link component and set the toProperty to the slug. Then we just need to display the product's name, price, and description. Back into the product component, add some curly brackets, and then map through the array of products. And for each product, return a product thumbnail component. And then pass in the name property, the description property, the price property, and the slug property. And because this is an array of components, we do need to define a key property, and I'll set it to the product's ID. Save the file, and check out the results in the browser. We've got a list of products, but it isn't pretty, so let's add some styling. For this project, I am using Sass, but feel free to use any styling solution you want. So I'll create a few basic classes to add styling to. Import the style sheet into the component, and then assign the classes to the different elements. And now add some styling to the classes. And I'm going to speed through this because this video is not about writing CSS. And the styling that I'm going to write is very basic. When I click on the home link and then the products link, it takes a few seconds for the content to load. So we need to let the user know that the content is loading so they don't just hit the back button. So I'll create a new component in the components folder named loader, create the components function, and then return a JSX object. I'll wrap the component in a div and then add an h2 tag with the text loading. And of course, export the component. Back in the products component, create another state variable is loading, and set it equal to useState. Set the default value to true. In the useEffect hook, add a second then block, pass in a new function, and set isLoading to false. In the component's JSX, we'll add a ternary expression on the isLoading variable, and if it's true, display the loader. Otherwise, we'll display the list of products. Save the file and check out the results. And it works as expected. One disadvantage of this approach is if you implement code splitting, the user would have to wait for the products bundle to load before the getProductsNetwork request can be sent. I also didn't include any error handling in the useEffect hook. In a real network request, you need to catch any exceptions and recover from them. With React Router v6, we can define a loader on a route so that when the user navigates to that route, React Router will execute the loader for us. But to use this feature, along with many others, we have to set up a data router with the browser router. So open up the app component, select the router block, and comment the whole thing out. Open up the index.js file and create a new constant router and set it equal to create browser router. Make sure to include the import from React Router DOM, and then pass in a new array of objects. The first property in this object is going to be the path property, and we'll set it to the URL root. Define an element property and set the value to the app component. In the root.render function, select the browser router and app component, and then comment them out. Add a router provider component and set the router property to the router variable. Save the file and check out the results. And we've already got an exception. Of course, this is because we haven't yet defined the product's route, so remove that from the URL, and the app is working. But notice all the extra components in the developer tools that we didn't have before. Back into the index.js file, add a children property to the root route. And this is the same as defining nested routes when you define them through JSX. Add a new object for our new route and set the index property to true, and then the element to the home component. Save the file, and you'll notice that the home component isn't being displayed in the browser. The reason is because we need to add the outlet component to the app component. And now the home component is visible. Add another route, and this time we'll set the path property to products, and then the element to the product layout component. Now add the children property and set it equal to a new array. Add a new route and set the index property to true, and the element property to the products component. Add another route, and set the path property to the dynamic segment slug, and set the element to the product component. Now we need to get out of the products route and go up one level to create a new route. And this time we're not going to define a path property, just the element property, and we'll set it to shared layout. Add the children property, and then add new routes for both the contact route and about route. Our router is now functionally the same as it was before, but if you don't like defining your routes using JavaScript objects, we can also define them with JSX. So comment out this router block, and then create a new constant router, and set it equal to create browser router, and then create routes from elements. And now we'll define our first route using JSX. Set the path property to the URL root, and the element property to the app component. Add a child route to the app component, set the index property, and the element to the home component. Add another route, set the path property to products and the element to the product layout component. So, as you can see, you can define your routes using JavaScript objects or JSX, whichever you prefer. But for the remainder of this video, I'll be using JSX. In the last video, we added a catch-all route that was defined to the router in the app component. We can do the same thing here, but we also have another option. We could define an error element. The advantage of this is that if an exception is thrown in the render function of any of our components, the error element will catch it. It'll also catch any exception thrown in a route loader or action. React Router does this by wrapping the router with an error boundary. Now let's add a loader to the product's route. So add a loader property and set it equal to fakeAPI.getProducts. Open the products component and then select the useEffect hook and state objects and then comment them out. This will create some errors in the component's JSX, so remove the isLoading variable and loader component. Now create a new constant, products, and set it equal to useLoaderData. Make sure to include the import from React Router DOM. Save the file and check out the results. When I click on the products link, it takes a second before the navigation changes. From a user perspective, it looks like the app froze or it just doesn't work. What React Router is doing is it's waiting for the data to load before it performs the navigation. So we just need to let the user know this by displaying a loader. So I'll open up the app component and then create a new constant, navigation, and set it equal to useNavigation. Under the nav element, add some curly brackets and then type navigation.state == loading. And if that's true, we want to display the loader component. Save the file and check out the results. The nice thing about the solution is that it is global to the app. Anytime any route requires loading, this loader will be displayed. Back in the index.js file, add a loader to the product route. Pass in a function and destructure the first parameter to retrieve the request and params object. The request object is a standard request object from the fetch API, and the params object gives us access to the dynamic segments within the URL. Call the fakeAPI.getProduct, and then pass in params.slug. In the product component, remove the useParam hook and replace it with a new constant, product, and set it equal to useLoaderData. Then replace the component's JSX with a new h2 tag where we'll display the product name, then the price, and the other details about the product. Now when I click on one of the products, the loader is displayed and the navigation occurs. But what if we want the navigation to occur before the data is ready? Well, we can do that too. So back to the index.js file, and in the products loader, pass in a new function. And this time we're going to call defer, pass in an object with a key products, and set the value to the result of calling the getProducts function, which will return a promise. In the products component, destructure the products variable from the useLoaderData hook. Now import suspend from React. In the component's JSX, add the suspends component and set the fallback property to our loader component. Add an await component. This comes from React Router DOM, and in the resolve property, we want to pass in our products promise. Within the await component, add some curly brackets, and we're going to pass in a function. The first parameter to this function is the resolved product list. And then we're going to map through this product list, returning JSX components. This peculiar looking syntax is called render props, where we pass in a function as a child of a component, and then that component executes that function. Save the file and check out the results. And it works as expected. If you don't like render props, we can do this without it, but it does require creating another component, which I'll name product loader. And then we're just going to return, copy the mapping function, and then paste it into the new component. To retrieve the array of products, create a new constant, products, and set it equal to useAsyncValue. Inside the await component, remove the curly brackets and add the product loader component. Save the file and check out the results. Now let's do the same thing for the product route. Open up the index.js file, and in the product route, in the loader, we're going to call defer, pass in a new object with a product key, and the value set to fakeAPI.getProduct. In the product component, import suspends from React, add suspends to the component, and set the fallback to the loader component. Bring in the await component and set the resolve property to the product variable. Destructure the product variable from the useLoader data, and keep in mind that the product variable is a promise. Create another component named product loader. Create a constant variable named product and set it equal to useAsyncValue. And then return a JSX component. Cut the JSX from the product component and paste it into the product loader component. And then add the product loader component as a child of the await component. Save the file and check out the results. Now, if I modify the URL and add a value to the end of the slug, and then hit enter, the loading screen is displayed for a second, and then we get the error route, and the error boundary catches the exception. But we can display more information to the user, so open up the error route, and then create a new constant, error, and set it equal to useRouteError. In the component's JSX, add a p tag, and then access the error.statusText, or the error.message. Save the file and check out the results. You can also add a random URL that won't match a current route, and we'll just get a not found error. Notice that the error element doesn't display the navigation elements. We can change that. So I'll create a new route, and the only property that we're going to set in it is the error element, and we'll set it to the error route component. Make sure that this route wraps around every other route. Save the file and check out the results. Now, in the case of the unknown route, we're still displaying the error element defined on the route path. But if we go to the product page and modify the URL to include a random slug, the product loader will throw an exception, and the exception will be caught by the inner error element. So you've seen how we can use loaders to load data from an API, and we're not done with loaders yet. We will be coming back to them in a little bit. But we can also submit data to an API using actions. So I'll start out by creating a new component named newProduct. Create the component's function, and then return a new JSX object. Wrap it in a div and add an H2 element with the text newProduct. And then add a form component with a capital F. This comes from React Router DOM. Within this form, add a label component with the name property, and then an input component with the name property set to name. And because I'm too lazy to fill out the form myself, add a default value property and set it to faker.commerce.product_name. Add another label component with the text price. And then, of course, another input component. Set the name to price. And the default value to faker.commerce.price. So we'll just be repeating this process for every input element. We'll need a quantity input field and a description input field, which will be a text area. Add a button and set the type to submit, and then text to submit. And then export the component. Then in the products component, under the H2 element, add a link component and set the toProperty to new product with the link text set to new product. In the index component, add a new route as a child of the products route and set the path to new product. And set the element to the new product component. Now click on the new product link, and the form is pretty hideous, so I'll create a new style sheet. Define a form class. Import the style sheet and assign the form class to the form component. And then add some basic styling real quick. All right, that will work. In order for the route's action to be executed, the form submission method cannot be GET, so set it to POST. Before we can create the action on the new product route, we need to create an API that allows us to create a new product. So open up the fakeapi.js file, and in the fakeAPI object, create a new function named createProduct. I'll expect a new product object to be passed into this function, and then we'll call delay and pass a new async function with both the resolve and reject parameters. Add an ID property to the product object and set it equal to faker.datatypes.uuid. Add a slug property to the product object and set it equal to genSlug, and then pass in the product name. Now retrieve the current list of products from local forge. Add the new product to the list of products. And then save the list of products back into local forge. Finally call resolve, and then pass in the product object. In the index.js file, we'll add an action property on the new product route. And we'll set it equal to a new function, destructure the first property, and we're going to retrieve the request object. The request object comes from the Fetch API. So if you're curious about what properties and methods it contains, check out the MDN docs. To retrieve the form data from the request object, call the form data function. This function will return a promise, so then add a then block. Form data will return an array of key value pairs. But I want an object of key value pairs, so in the then block, pass in a method reference to object.fromEntries. Now that we've got our object of key value pairs, add another then block and pass in a method reference to the fakeAPI.createProduct function. And finally, I want to return the response from this request, so remove the curly brackets from the function declaration. Save the project and check out the results. So when I click on the Submit button, it really doesn't look like anything's happening. But let's click on the Products button, and then scroll down, you'll see we have a new product. So I'll go back to the New Products form and submit a new product just to make sure it's working, and then click on the Products link, scroll down, and you can see we have another new product. But right now, it doesn't look like the new product form is doing anything, so we need to add some feedback to the user. So open the new product component, add a new constant, navigation, and set it equal to use navigation. Underneath the H2 element, add some curly brackets, and then navigation.state equals submitting. If this is true, then I want to print out the text saving new product. To make sure that the user isn't able to hit the submit button more than once, I'm going to disable the button if the navigation.state equals submitting. Save the project and check out the results. When I click on the submitting button, the saving new product is visible and the submission button is disabled. If you want to redirect the user when the form data is submitted, then within the routes action, return the result of calling redirect, and then pass in the URL or relative URL to this function. Make sure to import redirect from React Router DOM. What about form validation? React Router doesn't provide that, but you can easily add that with a third-party library. Right now, the input elements are all uncontrolled, but you can change that by adding state and an event handler. You can disable the submission button if all input elements don't pass validation, or you can add an onSubmit event handler to the form, verify validation before allowing the submission to continue. You can prevent the form from submitting by calling event.preventDefault, and you can programmatically submit data using the useSubmit hook, which I'll go over in a few minutes. So you have a lot of options on how to handle form validation. Before we move on to the next section, we need to rebuild our product list and make it a lot bigger. So open up the fakeAPI.js file and find the gen_store function. Change the value being passed to genProducts to 100. Then in your browser, open the Applications tab, right-click on the Catalog key value pairs, and select Clear. Refresh the browser, refresh the catalog dataset, and you should have 100 products. Now back into the Products component. Under the New Product link, create a new Form component, add a new label element and an input element, set the name property to filter, and the placeholder to filter. The new product link is too close to the input element, so I'm going to move it off to the right. I'll wrap both the H2 element and the link in a new div. Assign a class name to the div. Add the class to the product Sass file, and then add some styles to shift the link over to the right. I'm also going to disable auto-completion on the input element. Now the text that I enter into the input element, I want to use that to filter out the list of products. Since I didn't add a submit button, just hit enter to submit the form. You'll notice that the global loader was displayed there for a second. Also notice that the text that I entered in the input field has been added to the URL as a search parameter. So open up the index.js file. And on the loader for the product's route, destructure the request object. Add curly brackets to this function. And make sure to return the call to defer from this function. Otherwise, the products component will throw an error when it attempts to destructure the result from the useLoaderData hook. Now we need to retrieve the search parameter past the product URL. So create a new constant and set it equal to new URL and pass in request.url. Create another constant filter and set it equal to url.searchparams.get and pass in the string value filter. I want this to be a case-insensitive filter, but the get method will return the string value if filter is a search parameter on the URL or null. So I'll use the OR operator on this function, and if it returns null, I'll return an empty string, and then call toLowerCase on it. And then pass the filter value to the getProducts function. Open up the fake API, and in the getProducts function, we're going to add the filter parameter. After the getItems function call, add a new then block, where we'll take the array of products and call filter on them. Pass in a new function where we'll take the product and check if the product name includes the filter string. Save the file and check out the results. And it works as expected. There are a few UI issues that we need to deal with. For one, the list of products is being filtered, but the value in the input element is blank, when it should contain the string that is being used to filter the result set. This happens anytime I hit the refresh button. Here I'll demonstrate it again. Add a new filter. Hit the refresh button. The list of products is still being filtered, but our filter input element is blank. To fix this, open up the index.js file, and in the products loader, we're going to add another key to the deferred object, and it's going to be the filter value. In the products component, destructure the filter variable from the useLoaderData hook. Create a new constant, filterRef, and set it equal to useRef. Add a useEffect hook and pass in a new function with an empty array as a dependency array. Now within the useEffect function, call filterRef.current.value and set it equal to filter. Add the filter variable to the dependency array, and then assign the ref to the input element. Save the file and check out the results. So the input element contains the filter string even after the browser is refreshed. Whenever the form is submitted, the global loader that is defined on the app component is displayed. This is good. We are letting the user know that something is happening and that the app's not broke. But it would be better to have our own dedicated loader for the filter function. I'm not going to take the time to create a spinner and position it next to the input element. I'm going to take a far lazier approach. So in the products component, create a new constant, navigation, and set it equal to useNavigation. Create a new constant, is searching, and set it equal to navigation.location and navigation.location.search. Now we're going to pass this value into a new URL search params object, and then call .has and pass in the string filter. Now the reason that I call the navigation.location object first is because the location object will be a null value most of the time. So I want to make sure that it's a non-null value before I attempt to call search on it and pass it into a new URL search params object. Under the form element, add some curly brackets, and then if is searching as true, print out a message to the user or display a fancy spinner, whichever you prefer. Save the file and check out the results. The global loader is still being displayed, so I'll modify it so that it only displays if there are no search parameters in the URL. Open up the app component and create a new constant, is loading, and set it equal to navigation.state equals loading, and navigation.location and navigation.location.search, and I'll negate the result of these two. Update the loader in the components JSX, and we'll check if is loading is true, then display the loader. One improvement that we could make to the filter function is as the user types in text, automatically submit the value. So create a new handle input event listener with the parameter e so we can get access to the event object. Now we need to be able to programmatically submit the form. So create a new constant, submit, and set it equal to useSubmit. Now in the event handler, call submit. We need to pass the form that we want to submit to the submit function. An easy way to do that is with the event object. So type e.currentTarget.form. Now add the event handler to the input element. Save the file and check out the results. To speed things up here, I'm going to decrease the delay in the fake API. After adding text or removing text from the input element, if you hit the back button, you'll notice that we have quite a few saved states in the history stack. I don't want every single keystroke to be saved in the history stack. So in the products component on the submit function, add a new object as a second parameter with the key replace and set it equal to false if the filter variable is equal to an empty string. You could also double negate the filter variable since a empty string will resolve to a false value, or you can pass the filter variable into the Boolean function to convert it to a true-false value. Now enter some text into the input element. And then when you hit the back button, the input element is empty. It would also be a good idea to add a debounce function to the input event handler. You can get one from pretty much any utility library out there or roll your own. And finally, what about catching network requests? React Router doesn't care where your data comes from, whether it's from a network request or local storage. But whatever caching solution you use, it has to function outside of React. The reason is because the loaders are defined outside of React, so you can't use a React hook or access the React context inside of a loader. With that said, many popular libraries work with and without React. Well, that is it for this video. If you like this video, then please like, share, subscribe, and I'll see you in the next video.